Quantum computing will do more than speed up technology. It will challenge the cryptography that protects identities, signatures, data, and PKI. In this topic, we'll turn that risk into a practical roadmap for quantum-safe, future-ready enterprise trust. We've already moved from AI transformation into governance, security, compliance, and digital trust. Now we extend that trust model forward. If quantum computing breaks today's cryptography, enterprises need readiness plans before the disruption arrives. Quantum risk is not a distant science fiction problem. Attackers can harvest encrypted data today and decrypt it later. If digital signatures fail, identities, AI agents, APIs, and audit trails can all lose trust. Harvest-now-decrypt-later means an attacker does not need to break encryption immediately. They can copy encrypted traffic, backups, archives, or data lake contents, store them, and wait. If quantum computing later weakens today's public key cryptography, that captured data may become readable. This matters most for information with a long confidentiality lifespan, such as health records, financial data, intellectual property, and regulated government data. If it must stay secret for 10 years or more, migration planning starts now. Quantum risk also threatens the systems that prove something is authentic. PKI works because roots, intermediates, and certificates form a chain of trust. If RSA or ECC signatures in that chain become forgeable, attackers could fake software updates, identities, API clients, legal documents, or AI model attestations. So the challenge is not only replacing encryption, it is preserving confidence in who signed what, when it was signed, and whether historical records can still be trusted. Post-quantum readiness is not a one-time algorithm swap. It is an architecture capability. First, build cryptographic agility, so keys, algorithms, libraries, and providers can change without breaking the business. Next, protect information based on how long it must stay secret. Then migrate by risk, starting with exposed, high-value, long-lived systems. Finally, preserve trust continuity, so identities, signatures, certificates, and audit evidence remain reliable throughout the transition. The first migration pattern is discovery. Before choosing post-quantum algorithms, build a living inventory of every place cryptography appears: applications, APIs, databases, certificates, HSMs, protocols, libraries, devices, and vendor services. For each item, capture the algorithm, key size, owner, protected data, certificate lifecycle, and required confidentiality lifespan. The real value is prioritization. Hidden dependencies and long-lived sensitive data move from vague concern to visible, ranked quantum risk. Crypto agility means designing cryptography so it can change without rewriting the business system. Applications should not hard code the algorithm, certificate, key size, or provider they use. Instead, they should call an abstraction layer governed by policy and backed by KMS, HSMs, certificate services, or platform controls. That gives teams a path to swap RSA or ECC for post-quantum options when ready. The practical test is simple. Can you rotate, replace, and validate algorithms in production-like conditions? Treat migration as a risk management portfolio, not a technical cleanup project. Start where quantum exposure and business impact are both high. Long-lived secrets, public-facing access, code signing, regulated data, and critical infrastructure. Medium-risk systems may wait, but only if dependencies are understood. Lower-risk assets still need a plan, especially when vendors control the timeline. Good sequencing balances cryptographic danger with outage risk, implementation complexity, vendor readiness, and continuity, so urgency does not create avoidable disruption. PQC readiness is a staged discipline, not a one-time upgrade. Begin by tracking guidance from NIST, NESA, CNSA, ISO, and relevant regulators. Then map where cryptography is used and explore algorithms like MLKM, MLDSA, and SLHDSA in safe test environments. Work with vendors early, because protocol support and tooling will vary. Before moving into production, validate latency, certificate size, handshake behavior, interoperability, and operational impact. Quantum-safe PKI is about keeping certificate trust intact while the algorithms underneath change. Start by mapping roots, intermediates, policies, issuance, revocation, and every relying party that validates certificates. Then decide where hybrid certificates make sense and where pure PQC can wait. Expect larger keys, bigger signatures, and compatibility limits in protocols and applications. The safest migration is automated, governed, and backed by HSMs that can protect new signing keys without weakening existing trust anchors. Hybrid cryptography is a bridge, not a destination. During migration, a connection can use both a classical algorithm and a post-quantum algorithm, so security does not depend on either one alone. The same idea applies to signatures through dual signing while relying parties catch up. There are trade-offs: bigger messages, more processing, more testing, and more interoperability risk. Use hybrid designs to reduce transition risk while still building toward crypto agility. At the enterprise level, post-quantum readiness becomes a trust architecture, not just a crypto swap. AI-enabled organizations must prove who acted, what artifact was used, where data came from, and whether evidence remains verifiable years later. That means human, machine, and agent identities connect to PKI, HSMs, key management, service mesh, signatures, credentials, provenance, and audit logs. The goal is durable assurance. Today's decisions can still be trusted when algorithms, platforms, and threats have changed. Enterprise readiness starts with knowing your exposure. Inventory cryptography, assess crypto agility, and evaluate data lifespan, PKI, vendors, and governance. Then move in waves: discovery, risk assessment, pilots, high-risk migration, broader rollout, and continuous monitoring. Track progress with practical KPIs, such as assets inventoried, certificates remediated, PQC pilots completed, and crypto agility coverage. Long-lived data deserves attention now. The key rule is simple: you cannot migrate what you cannot find, and crypto agility is the bridge to quantum-safe readiness. Post-quantum readiness is about acting before trust breaks. Know where cryptography lives, prioritize what matters, build crypto agility, and pilot quantum-safe patterns. Protect long-lived data, signatures, identities, and evidence. Next, we expand from trust infrastructure into enterprise AI transformation, maturity, roadmaps, operating models, and capstone application.